Alright, so now let's take a look at endothermic changes. An endothermic change is a change in which heat energy is absorbed from the surrounding. Alright, or you can say that heat energy is taken in from the surrounding. Always remember endothermic, E-N, enter. Alright, heat energy enters the system from the surrounding. When an endothermic change occurs, number one, heat energy is absorbed from the surrounding. Number two, temperature of the reaction mixture falls. The container feels cooler. Always remember, the reaction mixture over here, we are actually referring to the surrounding. Okay, so the surrounding is actually the reaction mixture. Alright, so for example, when the solid ammonium chloride crystals will dissolve in water. Alright, so this is actually a physical process, but this process, alright, requires heat energy to be taken in from the surrounding. So based on this observation, heat energy was absorbed from the surrounding. We know that this is actually an endothermic reaction. Right, so temperature of the reaction mixture drop. Alright, so this is called endothermic reaction. Okay, let me emphasize again. The surrounding in this case refers to the reaction mixture. Right. So bond breaking is an endothermic process. Heat energy is taken in when a bond is broken. Right. In order to break a bond, you need to supply heat energy so that heat energy can be taken in to break the bond. For an endothermic change, the enthalpy change is a positive value. Okay, so let me share with you the same analogy again. So we have the before state and we have the after state. So before the reaction, the energy level is low, right? But after the reaction, the energy level is high because heat energy is taken in from the surrounding. Therefore, you can see that the enthalpy change has a positive value. Alright, the enthalpy change, delta H, has a positive value. Okay, look at the direction of the arrow is going up. Alright, so it has a positive value because heat energy is actually taken in. So it goes from a low energy level to a higher energy level. Alright, let's try to analyze the same this graph again. Alright, same thing, if when you look at the y-axis, temperature, we are referring to the temperature of the surrounding. Right, so you see temperature decreases, temperature drops, so we can tell that this is actually an endothermic reaction. Right, so the temperature drops until the lowest temperature is reached. Okay, how do we know that the reaction is completed over here? Because there is no further decrease in temperature. Alright, so this is the lowest that it can go, so the reaction is completed here. Right, now if the reaction is already completed, why is it that the temperature doesn't remain constant at this temperature? Why does temperature slowly creep back to room temperature? Reason is very simple. Because heat travels from a region of higher temperature to a region of lower temperature. In this case, this lowest temperature is way below the room temperature. Therefore, when the reaction is completed, the temperature of the reaction rises until it reaches the room temperature. Right. Now this slide is very important. Examples of endothermic changes. Okay, similarly we have both the physical and the chemical reactions. For physical processes, the first example is melting. Okay, when you melt a solid to become a liquid, you need to supply heat energy. Alright, heat energy is actually taken in, and therefore temperature of the surrounding drop. So this is endothermic. Okay, same goes for boiling, right? When you boil a liquid, it becomes a gas. So this one requires a lot of heat energy to be taken into the system. Right, you need to take in the heat energy from the surrounding, and therefore temperature of the surrounding drops. Last but not least, when you dissolve some of the soluble salts, copper 2 sulfate, potassium nitrate, ammonium nitrate, ammonium chloride. Now all this, when you dissolve all this solid in water, you need to supply heat energy. That means to say heat energy is taken in from the surrounding. So this is an endothermic reaction. For chemical reaction, there are three. The first one is photosynthesis, action of light on silver bromide in photographic film, and thermal decomposition. Okay, let's take a look at thermal decomposition. Right. In order to decompose copper to carbonate, you need to supply a lot of heat. Alright, so heat energy is taken in, right, from the surrounding to break down copper 2 carbonate into copper 2 oxide and carbon dioxide. So this reaction is endothermic. Heat energy is taken in, temperature of the surrounding drops. Alright, reaction of acids with sodium carbonate is an exothermic change, but the reaction of acids with sodium hydrogen carbonate is an endothermic change. Okay, there is actually no way to predict whether is it exothermic or endothermic. Okay, so the scientists, they actually perform the experiments. Alright, they perform the experiments and they realize that reaction of acid with sodium carbonate is exothermic, but reaction of acid with sodium hydrogen carbonate is endothermic. Okay, for this kind, you need to look at the bond breaking and bond forming processes, and then you can actually predict whether it's exothermic or endothermic. But this will be covered when you advance to JC, or when you move on to poly and then you decide to study chemistry. But at your level, you just need to know what are some of the basic examples of endothermic reactions. Right. Okay, question number 1. Alright, so this is the first question. Okay, number 1, when I add sodium hydroxide pellets, so this is what I mean by pellet. Alright, solid pellet, you add it to water, okay, and then you stir it with a glass rod, then you measure the temperature before and after adding sodium hydroxide pellet. Then you perform the same experiment, but instead of using sodium hydroxide, you use ammonium chloride. Alright, okay, so you have experiment 1 and 2 using different solid, and then you measure the temperature. Okay, the first one, increase in temperature is registered. For the second one, a decrease in temperature is registered. Okay, I don't know how many times I have emphasized, but the temperature here, we are referring to the surrounding temperature. Okay, so in this case, for experiment 1, the surrounding temperature rose. Experiment 2, surrounding temperature drop. Okay, so question 1, which experiment shows an exothermic change and why? Part B, which experiment shows an endothermic change and why? Alright, so experiment 1 is an exothermic change because there is an increase in temperature in the solution. In this case, the solution is actually the surrounding. For part B, experiment 2 shows an endothermic change because there is a decrease in temperature in the solution. Question 2. The reaction between aqueous sodium hydroxide and hydrochloric acid is exothermic. Which graph shows the change in temperature when aqueous sodium hydroxide is added to hydrochloric acid until the alkali is present in excess? Alright, in this case, the alkali is actually sodium hydroxide. Alright, and the question already says the reaction is exothermic. Alright, the answer is B. Alright, straight away you can eliminate options C and D. Since the reaction is exothermic, heat energy is released to the surrounding. Therefore, the temperature of the surrounding should increase. So it's either option A or option B. Okay, but A cannot be the answer because when all the hydrochloric acid has been reacted, then there is no more reaction. The reaction is already completed at this point. When the reaction is completed, okay, the temperature will actually drop to room temperature. You cannot expect the temperature to be maintained at a very high temperature when the reaction has already stopped. Okay, so B